Welcome back everyone. In today's session we are going to begin exercise 5.2. Before we go for that, let's recall what we did in the last session. In the last session I explained you about arithmetic progressions, which type of series are called arithmetic series and which are not. So I said you if we have the common difference, then that type of series are arithmetic series. If we do not have the common difference, then they are not called arithmetic series. So we were getting the next term of arithmetic series by adding the common difference, like after 2 comes 6 by adding 4, then again 6 plus 4 gives you 10, then 10 plus 4 gives you 14, goes on, then 14 plus 4. If I ask you what is the fifth term, what is A5 in this, so you can easily say 14 plus 4, that is 18. So we were limited to this method. By adding the common difference, we were getting the term. Now suppose if I ask you what is 15th term in this series, what is A15 in this, or if I ask you what is 100th term in this series, then it will be difficult for you. You cannot go on add till 15 terms and get the numbers, or you cannot go on add till 100 terms. That will be time consuming, isn't it? So to find this type of terms, okay, to find any term of the series, okay, we have a formula for that. We are going to discuss about that formula today. So the formula is an is equals to a1 plus n minus 1 into d. Okay, so where an will be, you can see these are the details, okay, where an will be nth term in the sequence. Okay, any term, an is nth term. Nth term means it can be any term. It can be 100th term, it can be 15th term, it can be 99th term, any term it can be. Okay, and a1 is the first term. Okay, we will not take a1 always. Okay, we can just write a also here. Okay, so instead of writing a1, a also you can write a1 plus n minus 1 into d. So this is the formula for finding any term of the series. Either you write a1 here or you just write a, both are same. So a1 will be the first term in the series. This is your a1. What is a1 here? 2. N is the number of terms. Okay, if you are finding 15th term, okay, I'll show you how to find one of the term from this. Okay, we'll do an example and understand this problem. N will be the number of terms, okay, and d will be the common difference. What is common difference in this? The common difference is 4. Okay, suppose if I want to find 10th term of this series, what will be 10th term in this series? So that's very simple. I'll apply the formula. a1 is 2 plus n. What is n in this? N is here nothing but 10. So 10 minus 1 into d. What is d here? D is 4. So if I simplify it, I'll get 2 plus 9 into 4. That gives you 2 plus 9 4 is 36. Okay, 2 plus 36 gives you 38. So 10th term of this series will be 38. You can just, for checking, you can go on add 4 in this and get the 10th term. 18 plus 4 is 22, then plus 4 you do 26, then plus 4 30, then 34, then 38. So the 10th term will be 38. So this is the formula which can be used to find any term of the series, any arithmetic series. Not only this, you can find any term of any arithmetic progression. So let's see another example. Suppose if you have a series like 5, 10, 15, okay, 15, 25, 15, 20, okay, so on. What is the first term in this? A1, or I can say A also. A is 5, and what is the common difference in this? Common difference is you can subtract A2 minus A1 or A3 minus A2 or anyway, okay, you can find common difference. So usually we use A2 minus A1, that is 10 minus 5, 5. Okay, which term do you want to find from this now? 4 terms are given here. If you want to find, say, 11th term of this series, I want to find 11th term of this series, so I'll use the formula A plus n minus 1 into D. Okay, what is the formula? The formula is A plus T of n is A of n or T of n, both are same. Okay, you can write A of n or you can write T of n. So A of n is A1 plus n minus 1 into D. Okay, here I wrote T11, that is 11th term. Okay, if you want, you can write A11 also, T11 or A11, both are same. Okay, so if I want to find A11 here, A11, what is our n value in this? N is 11. What is A1? A1 is 5. Okay, A1 is 5 plus n is 11, 11 minus 1 into D. What is D? Common difference 5. So 5 plus 10 into 5. So 5 plus 50, that is 55. Okay, so 11th term of this will be 55. You can check 11 5 is 55. So there are in few series it will be easy for us to just count and calculate in our mind and say, but in few of them we need to apply the formula. So this is the formula which we are going to use in our exercise 5.2. Now in this exercise 5.2 in this formula, an is equals to a plus n minus 1 into D. We have 4 different parts. One is an, then a, that is first term, n and D. Okay, so in this formula we have 4 parts. First is an, you can see in this table also, an, then a. Okay, a1 or a, both are same, always remember it. The first term is a always, and this is n and D. So there are 4 different parts in this formula, and in this table, out of those 4 parts, one is missing. Okay, like in the first question, a is given 7, D is given, n is given, we don't know what is an, so we are going to find the missing values in this table. So in every bit one term is missing. Okay, in second one D is missing, in third one A is missing, in fourth one N is missing, and in fifth one again AN is missing. You can check out. So to find all these things we use one common formula, that is AN is equals to A plus n minus 1 into D, the formula which I explained you just now. Okay, and AN and TN both are same. In few books you find AN, in few references you find as TN. So always remember they both are not different, they are same. Now we'll begin with the first. In the first bit, A is given, A, D and N values are given, AN we have to find. So very simple, N value is 8, so I have to find A8. What do I have to find? AN. AN is nothing but I have to find what is the value of A8, because N is 8. So what is the 8th term of this series? The formula we have taken. Now we'll put the values. A value, what is A value? 7. Then n minus 1 plus n minus 1 is 8 minus 1 into D. D is 3. Okay, we'll simplify this all. 7 plus 7 into 3, that is 7 plus 21, that gives you 28. So 8th term of this series is 28. In this way we find the missing values by using the formula. So out of these 4 parts, okay, an is equals to a plus n minus 1 into d. Whatever is missing we can easily find by using this formula. Now let's see the second bit. In the second bit d is missing, that is common difference is missing. So again I wrote the same formula, an is equals to a plus n minus 1 into d. A value is given to us, n is given, an is also given, the term is also given to us. Okay, the term is also given. We have to find the common difference of that arithmetic progression. So in place of an I'll write 0, because an is 0. I'll substitute all the values. A is minus 18 and n minus 1 becomes 10 minus 1 into d. We don't know what is the value of d, so I have written d only there. So this becomes, this minus 18 goes to the left, it becomes plus 18 by transposing. So 9d is equals to 18, so d will be equals to 2. So this way we can easily get the missing values. Now let's see the third one. In third one, a is missing. What is missing? A. So again I use the same formula and substitute all the given values in the formula. So d value is given as 3, n is 18 and an is minus 5. Substituting an is minus 5. Okay, then a, we don't know what is the value of a, so I have written a only. N minus 1, 18 minus 1 into d is minus 3. Simplifying this all, so 18 minus 1 is 17. 17 into minus 3 gives you minus 51. So a value will be minus 5 plus 51, that will be 46. So this way we find the value of a. In the same way you have to continue with the other bits, that is the 4th bit and the 5th bit of this question. Okay, complete this in your classworks.